we are going to discuss about Newton's second law of motion. It's a very important topic in chapter motion and it is very interesting also. It's a simple concept based on motion. We are going to consider an example of ball. It's a ball and the mass of this ball is m. The velocity of the ball is u. We are considering a ball. The mass of the ball is m and velocity is u. And we are applying a force F on that ball. When we are applying force, it will move. When we are applying force, it will move, right? Now we applied a force. Now the mass is m because the mass is universal constant. The mass is not going to change. But the velocity will change. The initial velocity was u. Now the velocity is v, the final velocity. There are two velocities now, initial velocity and final velocity. Now we need to revise one topic, that is momentum. What is momentum? Momentum is the special property of moving object. And the equation for momentum is m into v, mass into velocity. Here there are two velocity. One is initial velocity, one is final velocity. Then there will be two momentum. One is final momentum and other is initial momentum. Force is applying for the duration of t. The time duration of the application of force is t. Time is t. Now we can find the initial momentum and final momentum. The mass is m, initial velocity is u, the final velocity is v. What is the equation for momentum? Initial momentum is m into u. Initial momentum equal to m into u, mass into velocity, mass into initial velocity. And final momentum is m into v, mass into final velocity. From these two momentum, how can we find the change in momentum? To find change in momentum, we can subtract initial momentum from final momentum. That is, change in momentum equal to final momentum minus initial momentum. Now we can substitute all the values here. Initial momentum is mu, final momentum is mv. Then, change in momentum will be final momentum minus initial momentum means mv minus mu. Right? Instead of final momentum, we can give mv. Instead of initial momentum, we can give mu. Then it will be mv minus mu. What do you mean by rate of change of momentum? How we can find rate? Rate is related to time. When we are dividing this change in momentum by time, then we will get rate of change of momentum. The rate of change of momentum will be equal to mv minus mu by t. Now it is rate of change of momentum. What is the reason for this rate of change of momentum? When it started, when we are applying a force, then only the ball is moving. When we applied the force, the ball has been moved, right? Means if we are applying more force, the rate of change of momentum will be more. If we are applying less force, the rate of change of momentum will be less. The rate of change of momentum will depend on the force, the applied force, the external force. Here we are applying a small force, then the rate of change of momentum will be very small. When we are applying a large force, the rate of change of momentum will be large. So we can say that rate of change of momentum is depends on force, it is proportional to force. If we are increasing force, the rate of change of momentum will increase. What is the reason for this rate of change of momentum? Force proportional to rate of change of momentum. It is Newton's second law. So what is second law? Rate of change of momentum is proportional to force. Rate of change of momentum of an object is proportional to applied force. Now we can write Newton's second law of motion. The rate of change of momentum of an object is directly proportional to applied unbalanced force and the object moves in the direction of force. Now we can write mathematical formula for second law of motion. Mathematical formulation of second law of motion. According to second law of motion, force is proportional to rate of change of momentum. So we can write the first step is force proportional to rate of change of momentum. What is this rate of change of momentum? It is final momentum minus initial momentum by t. Then we can write rate of change of momentum equal to mv minus mu by t. mv is final momentum and mu is initial momentum and t is time duration. Instead of this rate of change of momentum, we can write mv minus mu by t. Here this m is common. mv is having m, mu is also having m. We can take this m out, right? Force proportional to m into v minus u upon t means m is common in both terms. So we are taking it out. What is this v minus u by t? you are familiar with this term v minus u by t, it is acceleration. Then v minus u by t, we can write it is acceleration. V minus u by t is equal to acceleration. Then we can substitute this a instead of this v minus u by t. It will be force proportional to ma. Instead of v minus u by t, we are using a. To remove this proportionality sign, to replace this proportionality sign with equal, we need to add a constant. That constant is k. Then we are taking k is equal to 1. Then our equation for force will be F equal to ma. It's a very important equation. We have lot of numerical to do with this equation, and the equation is F equal to ma. So Newton's second law state that rate of change of momentum is directly proportional to applied force, and the object moves in the direction of force. Subscribe our channel for getting instant notification of sample paper solution, and support us for providing free online classes to everyone. www.winpointonlineclasses.com